when it comes to this complex carbohydrate, we saw about the simpler carbohydrate. When it comes to the complex carbohydrate, so starch and glycogen are the storage polymers of glucose in plants and animals. So in animals, it is going to be the glycogen, and in the plants, it is going to be the starch. So when we consume lots of starch, it has to be broken down to simpler carbohydrates. We saw starch is a major part of the source of energy in the diet, and that has to be broken down. Thus, digestion of starch begins with the action of amylase enzymes secreted in the saliva and small intestine, which converts them into maltodextrins, maltose, limit dextrins, the non-resolving dextrins, so and some glucose. So they are acted by enzymes which are coming from the saliva and pancreatic amylase, where the digestion begins, and they get it converted to, the starch gets converted to maltodextrins, maltose, dextrin and some glucose. So after this, the digestion of limit dextrin and disaccharides. So it all gets into limit dextrin and disaccharides, which comes both from the dietary or from the starch derived to monosaccharides, which can be converted to. So these limit dextrins and the disaccharides has to be converted to glucose, galactose and fructose, is accomplished by enzymes located on the luminal surface of the enterocytes lining the microvilli of the small intestine. So what do we need to know? So the digestion begins right from the time comes from the smaller intestine. The amylase enzyme acts, which comes from the pancreatic juice, and that is what it acts. After that, we have the limit dextrin and disaccharide. So these disaccharide has to be converted to glucose, galactose and fructose. So they become the monosaccharides. That is how it can be absorbed. So this conversion of this limit dextrin and disaccharides to the monosaccharides is accompanied by enzymes, which are these enzymes are located on the luminal surface of the enterocytes. So we will show in the next image. So they are caused by the enzymes which are located on the luminal surface of the enterocytes lining the microvilli of the smaller intestine. Just remember this. I will show you in the next chart how it happens. So this is accompanied by these enzymes. These enzymes which convert this dextrin and disaccharides, these enzymes are which converted into glucose, galactose or fructose. So this is called as this alpha glucosidase enzyme. So this alpha glucosidase enzyme is a generic term for a family of enzymes that catalyze the hydrolysis of the alpha glucose. So you have a 1,4 bondage over here and 1,6 bondage over here. So the glucose molecules are attached like this. So if this glucose molecule has to be split up, it is acted by the alpha glucosidase, and this alpha glucosidase makes this glucose gets detached from this starch, so that this glucose can be easily absorbed. So we need to understand the starch has to be broken down. When it gets broken down, it gets converted to glucose. So the conversion of starch to glucose is done by this alpha glucosidase enzyme, which acts on the 1,4 bondage and leaves the glucose, and this glucose which gets cleaved from the starch gets easily absorbed. So it causes the release of alpha glucose molecule. So as you see in the chart over here, it is very, very pictorial. You have the villus, which is present in the small intestine. So this villus is, this part of it is enlarged and shown beautifully over here. We have the enterocyte, and they are the breast border cells, and these are the luminal side of the enterocytes. We said this image is expanded further over here. So this shows like these are the microvillus where this alpha glucosidase enzymes are present. So these alpha glucosidase enzymes, as you see over here, they are present on the luminal surface of the breast border cells. So this is the small intestine which has the villus, and this villus has the enterocytes, and the enterocytes have the breast border cells, and this is the luminal surface, and this luminal surface at the microvillus, these alpha glucosidase enzymes are present over here. So these alpha glucosidase enzymes are essential for the conversion of so if you see over here, this provides as a substrate. This provides as a substrate for the maltose, maltodextrins and dextrin. They will come and sit over here, and this will get this alpha glucosidase enzyme. At this point, it will split the glucose from this maltose, maltodextrins and dextrins, and they will get absorbed into the circulation. So that is how it happens. Now the molecule that we are talking about, so the alpha glucosidase is sitting on the luminal surface of the breast border of the smaller intestine. Now this alpha glucosidase inhibitor, they competitively inhibit the activity of alpha glucosidase enzyme. So this alpha glucosidase inhibitors, they will go and sit on the place where alpha glucosidase are present, whereby they are not allowing the maltose, maltotriose and dextrin to get attached to the alpha glucosidase enzyme, so that the conversion of this maltose and dextrins to glucose will be blocked. So that is how these enzymes work. The alpha glucosidase inhibitors sit on the alpha glucosidase enzyme, and whereby it prevents the conversion of maltose and dextrins and sucrose to the finer monosaccharides. That is how the alpha glucosidase inhibitors work.